Now we also maybe define them. Next we have some questions like effects of force. What are the effects of force? Then we discussed it earlier. You write this discussion portion. Now we know about the another units of force which is not already given. Another units of force are gravitational unit of force. Gravitational units of force are the gravitational units of force. Gravitational units of force. Number one, CGS system. In CGS system, what is the gravitational unit of force? Gram force. Gram force. It is written as GF or gram weight, also used. Gram weight. G and WT is written. In CGS system, its unit is what are the units? Gram force or gram weight. It is written symbolized as GF, gram force. In FPS, not required here. FPS system, it is kilogram. Sorry, it is pound force. Pound force. Pound is the unit of mass. Pound force. 1 pound equal to 453 gram. 1 pound equal to 453 gram. Gram force. Here pound force. Pound force. It is written as LB and F or pound weight also or pound weight. Written as LVWT, but it is frequently used in the first. Pound force. And in MKS system, MKS or SI, it is kilogram force. Kilogram force, written as kgf or kilogram weight also. Now, what is the definition of gram force? That is, at first, it is the gravitational unit of force in CGS system. It is the gravitational unit of force in CGS system, and it is defined as the weight of a 1 gram body. Weight of a 1 gram body. That is, weight of a 1 gram body means weight of 1 gram body means a body of mass 1 gram. Earth towards its center. Earth pulls towards its center. This force of gravity, that is weight of 1 gram body, that is the force exerted by the earth towards its center, force of attraction here always towards its center, is called 1 gram force. 1 gram force means 1 GF equal to 1 gram into acceleration due to gravity. Acceleration, value of acceleration due to gravity. Acceleration due to gravity. In CGS system, obviously. In CGS system. What is the value of acceleration due to gravity in CGS system? Average value 981. 1 gram into 981 centimeter per second square. 1 gram into 980 centimeter per second square means 981 gram centimeter per second square, and this is nothing but dyne. 981 dyne. That is, if we convert absolute unit of force if we want to convert gravitational unit of force in absolute unit, then we must multiply the mass with the acceleration due to gravity in this unit, that is in CGS, FPS, MKS, MKS. Now, we know in a similar way, kilogram force is the, not absolute, is the gravitational unit of force in MK system or SI system, and we have defined as the weight of a 1 gram body is called 1 kilogram body is called 1 kilogram force, and it is also defined as the force of attraction by the earth towards its center. Force of attraction of 1 kilogram mass towards its center. Hence, 1 kilogram force obviously equal to 9.81 Newton. 9.81 Newton. Because kilogram and force, here kilogram into G. G means value of G, average value. G equal to, in CGS system, 981 centimeter per second square. In FPS system, CGS, FPS system, we give FPS system 32.2 foot per second square. FT, this is foot, and G in MKS or SI system is 9.81 kilogram per meter square. We multiply them and convert gravitational force, unit of gravitational force, into unit of absolute unit of force. Now, we know about pressure. We know about pressure. We know about pressure. We know about pressure. What do you mean pressure? Pressure. Define pressure. What do you mean by pressure? Pressure is defined. Pressure is defined as the normal force. Normal means perpendicular. Normal, that is perpendicular. Perpendicular force acting on, pressure is defined as the normal or perpendicular force acting on area. What is the area? Per unit area. Acting per unit area. Per unit area of a surface of a body. That is, we consider pressure is defined as the normal force acting per unit area of the surface of a body. That is, this is the body. Remember, understand this. This is the body. We write it, we figure it in this way. And it is the normal force acting on a unit surface. That is, if this area is A or dA, then obviously P equal to A by dA. Or if it is A, then we write A by A, F by A. Now here we have two terms in the case of pressure, relation of pressure. Pressure is the force, normal force. This is the normal force acting, normal force, that is perpendicular force. This is perpendicular to the surface, 90 degree. Normal force, this is the surface area. If its total area is A, then this is the surface area. A is the surface area of a body, obviously. Hence P equal to normal force by surface area. Now, is it a scalar or a vector quantity? Pressure. Pressure always a scalar quantity because it has no direction. It has only magnitude but no direction. In this case, we see the normal force. The direction of force is mentioned here already. Direction of force, if direction of force is oblique, then it takes normal to the surface. Each component takes normal to the surface. Hence, pressure is a scalar quantity, not vector quantity, because it has only magnitude but no direction. Here, the normal force, that is direction of force, already mentioned. No direction is required to define pressure. In this case, only force is normal, that is perpendicular to the surface. Its unit in CGS system is Pascal or Newton per meter square. Pascal or Newton per meter square. If 1 Newton normal force acting on 1 meter square surface area, then the pressure will be 1 meter per second square, and it is defined as Newton per meter square, or it is written as Pascal. Pascal is the unit of force. Meter per second square or Pascal. It is abbreviated as P, capital P and small a. Meter per second square or Newton per Newton per second square, Newton per meter square, Newton per meter square or Pascal. That is, if 1 Newton force acting normally on the surface area of 1 meter square, then the pressure exerted is 1 Pascal or 1 Newton per meter square. Now, pressure of a fluid. What do you mean fluid? Fluid is anything that can flow, that is liquid or gases. Fluid pressure and atmospheric pressure, we know this term. Atmospheric pressure, atmosphere has a gaseous substances and some particles also, dust particles, that is, and in the earth, it extends from the surface of the earth to about 120 kilometer. 120 kilometer. In this layer of surfaces, we take, and its total weight will be 4.5 into 10 to the power 18 kilogram. 4.5 total weight of into 10 to the power of 18 kilogram. That is 4 and 5 tenths of million billion ton. 4 and 5 tenths of billion, not billion, million billion ton. Remember this in language. 4.5 into 10 to the 18 kilogram. Here, we know the surface of air, layer of the atmosphere, is divided into 5 main groups. First, we have troposphere, then stratosphere, troposphere, 12 kilometer from the surface of the earth, then 12 to 45 stratosphere, and then mesosphere, and ultimately ionosphere and exosphere. Remember it and see in your textbook or another book in which atmosphere layer are given. That is troposphere, stratosphere, mesosphere. Next will be what will be the next? Mesosphere, ionosphere and exosphere. We discuss it in the another class so that you may understand. Now, atmospheric pressure. The pressure exerted on unit surface area of the earth by the column of air is called atmospheric pressure. We define as the standard atmospheric pressure. But the atmospheric pressure, what do you mean by atmospheric pressure? Atmospheric pressure is the pressure exerted by the Earth's atmosphere. Earth's atmosphere. It has weight. Earth's atmosphere per unit surface area. Atmosphere column from the surface of the earth, it when acts on a unit area. This is the unit area, and this is the column of air. It gives normal force obviously. Then the pressure of the atmosphere called atmospheric pressure or pressure of air pressure. Now, standard atmospheric pressure. We define standard atmospheric pressure. Standard atmospheric pressure. Standard atmospheric pressure. Standard atmospheric pressure is defined. It is defined, write it. It is defined as the 76 centimeter of mercury column, at 0 degree Celsius temperature, 45 degree latitude, and at the sea level, it is defined, that is standard atmospheric pressure is defined as the 76 centimeter of mercury column pressure, that is pressure exerted by 76 centimeter of mercury column at 0 degree Celsius temperature, 45 degree latitude, and at the sea level. Remember this definition. We find the value of 1 atmospheric pressure. 1 atmospheric pressure. 1 atmospheric, that is standard. 1 standard atmospheric pressure. 1 standard atmospheric pressure equal to P equal to H rho G, H rho or D, rho G. That is height of the air column 76 centimeter. Rho means density of mercury 13.6 gram upon centimeter cube into CBSE system 981 centimeter per second square acceleration due to gravity. Standard atmospheric pressure. Here P is the standard atmospheric pressure. H is the height of the mercury column. H is the height of the mercury column. H equal to height of mercury column. Mercury H, write it. Column equal to 76 centimeter here. Mercury column. Rho equal to density of mercury in CGS system, obviously. Density of mercury in CGS system. CGS system, which is equal to 13.6 gram per centimeter cube. Gram per centimeter cube. And G equal to average value of acceleration due to gravity. Average value of acceleration due to gravity. Acceleration due to gravity. Due to gravity. And its average value is 981 centimeter per second square. 981 centimeter per second square. These values are taken in this type, and we have in this way we have the value of 1.01325. 1.01325 dyne per knot into 10 to the power 6 dyne per centimeter square. And if we converted this into SI system, then we have 1.01325 into 10 to the power of 5 Newton per meter square or Pascal, PA, P capital P, PA, right? This standard atmospheric pressure is this. Now the pressure of a fluid is measured by manometer, a simple device, and atmospheric pressure actually measured by a barometer. We discuss the next chapter and the related questions in this chapter in the next class. Thank you.